In the third video of this series, I showed you how to produce a frequency table. But quite often what we want to do as a means of preliminary inspection, but also as a piece of analysis in its own right, is to look at how the distribution of a variable varies within categories of a second variable. So this is our first introduction to bivariate analysis. And we can do this using any combination of two nominal or ordinal variables via cross-tabulation. Depending on the reading that you're using, you may also see these referred to as either pivot tables or contingency tables. The procedure to do it is to go up to Analyze, Descriptive Statistics, and Crosstabs. Now there are a few conventions about the layout of a crosstab, and the general rule for these is that you want your percentages to sum to within categories of the independent variable. There's a couple of rules of thumb I'm going to show you to lay these out. This is just the way that I lay them out. Some texts emphasize putting the dependent variable in the column, some emphasize the row, but what matters is that the percentages sum to 100 within categories of the independent variable. And I'll show you what that means in a moment. So in this example, I'm going to look at the relationship between voting and education. And if we phrase this in the language of hypotheses, we might hypothesize that the likelihood of voting varies by level of education. Maybe that's positively or negatively, perhaps more education, or the higher the level of education, the greater the likelihood of voting. So in that setup, voting is our dependent variable and education is our independent variable. So we're going to start with vote. Now by this convention, we place the independent variable in the row and the dependent variable in the column. So we'll transfer vote over to column. Our independent variable is going to be education, and we'll use this little recoded education grouping variable down here and transfer that to the row. You can also, if you wish, add additional layers to this to make it a three-way or a multi-way table. But again, you got to be careful with this because, as I'll talk about in later videos, we do get into issues of sample size and cell count, and also table complexity and size, depending on the type of variables we use. There's a few additional settings we need to make before clicking OK. Under statistics, we have a number of different options. And in a couple of videos' time, I'll be talking about what the chi-square and the Kramer statistic are going to tell us. But we can activate any of these by just simply clicking in the checkbox. Under cells, we want to be careful to make sure that for this type of configuration with the independent variable in the row and the dependent in the column, that we click row percentages. There's also a number of additional settings here that we'll come back to in a couple of videos' time as well. And then finally, there are a number of different options around format, around style, if we have a pre-formatted style, and about bootstrapping. We can also ask it if we want to return clustered bar charts. But again, if you do want to build a bar chart to report in your final analysis or your assignments or your report write-up, you might want to do this by using Chart Builder, which lets you adjust some of the settings with more precision. When you're happy with your settings, you click OK. And we get, first of all, a case processing summary that shows us our number of cases and our percentage missing cases. And that gives us a table. So when we talk about the general rule of setting up tables so that they sum to within categories of the independent variable, what that means is that as we read across each of these percentage cells here from left to right, again, given the way that I've set this table up, that we have a sum to 100 over here in this total column running vertically along this side. So what that means is that each of these cells within each of these rows now, this is telling us the percentage of respondents with primary education who voted yes, the percentage of respondents with primary education who voted no. This is the percentage of respondents with secondary who voted yes and who voted no. As we read down through this, then we can look for subtle changes in the distribution of responses within each of these different categories. So we see here we've got a more or less sort of uniform decline, although it's far from straightforward. The highest propensities to voting are in the primary group, and they sort of drop to a consistent low then between the secondary, PLC and degree group. And there's not a whole lot of variation between these three groups either. As we move further down, you'll see it's also returned for us a bar chart, but this is less useful because the default axis in this is set to count rather than percentage. So if we were reporting a bar chart in our write-up, we would want to set this up perhaps with a little bit more precision in Chart Builder. One of the things you want to watch out for in producing a cross-tabulation is the issue of small cell counts. We'll talk about why that's important in the video on returning and interpreting the chi-square, but if you see here, we've got these cells that have relatively few cases in them. So we see here in this cell, for within the primary group, there were only 2 individuals who were recorded as not eligible to vote. There's another issue as well in producing these tables, where we want to take care of the size and the complexity of the table. Beyond a certain point, these become quite difficult to read. So if you can imagine, if we were looking at, let's say, the relationship between voting and occupational group, if we were to include in this our occupational grouping variable, we'll look at the ISCO categories and see what this looks like. You can see that quite quickly in a variable with a large number of categories, the table becomes quite large and can be quite difficult to read. So in this case, for a variable with a large number of categories like occupational group, this is not really, this doesn't really make a whole lot of sense, and it's not especially useful for assessing relationships. So again, if we were trying to do some kind of analysis with a variable like occupation, we'd probably want to either recode this into something more legible, into subgroups, or perhaps choose a different variable that uses a smaller number of categories. But one thing that we can do, and that's quite a common procedure, is to introduce an additional layer into the cross-tabulation. So we'll return to our original setup, which was education by vote. And you'll see here in the layer field, we can include an additional variable that will allow us to split the table even further. Now again, when we start introducing sublayers, we again need to be very attentive to the possibility that we're going to encounter very, very small sample sizes or cell sizes with some of these. But again, we'll talk about the technical properties of this in a later video on the chi-square. Once I find a layer variable, I can transfer it over here to the layer box and click OK. And now what it's going to do is return a series of tables that are split across each of the categories of that layer variable that I've included. So here we have a table for just males, showing the relationship between education and voting, for females showing the relationship between education and voting, and then for the total sample again. So this table is identical to the one that we produced in the first stage, where we had no additional layer set. And what this allows us to do then is to look within these different categories of gender and to see if there's any departure from the global relationship. So we see here that the totals, at least for those in primary education who voted yes, are more or less equivalent, about 84% versus 82% male versus female. And the difference across education groups is, somewhat, it's not terribly straightforward, but there does seem to be a slightly lower propensity to vote for males in the higher educated group relative to females. So this suggests to us perhaps there is something going on here, that perhaps the education and the gender variables are relevant to explaining voting patterns. But of course, in the full analysis, we would perhaps want to include a variable that's a little bit more sensible than just gender. So you can think of there are perhaps additional factors that might be related to this that we can substitute and include as layers as well. Nonetheless, the general rule with these is to take care and be careful that quite quickly, the more variables you add to this, the greater the complexity of the table.